right, so I'm going to talk us through two different ways to simplify complex fractions. So first of all, what is a complex fraction? A complex fraction is a fraction within a fraction. So we've got some fractions within a big fraction. And so there's a couple methods to solve this. I'm going to show you what I call method 1 versus method 2. And then you can pick the one that you like best, and that's what you would use for the rest of this packet. So I'm going to start, and I don't care which one you use. You can be a method 1 person or a method 2 person. Doesn't matter. You're still going to get the same answer either way. So for this first one, method 1, this is kind of like the old school way to do it. It's probably the way you first learned how to do these a long, long time ago, which is just you've got fractions in the top and fractions in the bottom. So what we'll do is we'll first get a common denominator here to change the numerator to one fraction. Then we'll do the same thing with the denominator separately. And then we'll use the rule for division of fractions, which is multiply by the reciprocal of the second one. So let's first start here. I've got 1/3 minus 1/4. So I want to rewrite those with a common denominator of 12. So the first one you're multiplying by 4, so that would be 4/12. The second one I'm multiplying by 3, so that would be 3/12. When I simplify that, I get 1/12. That's my new numerator. I do the same thing for the denominator. Got a common denominator of 8. So this is multiplied by 4, so I have 4/8. The second one just stays 7/8, gives me 11/8. This is now my new denominator. Once I now take a fraction, divide it by another fraction, I just use the rule of division for fractions, means multiply by the reciprocal of the second one. So I take the second one and flip it. Now the 8's on top, 11's on bottom. Here I can do some simplifying before I even multiply across. I can simplify because 8 and 12 can both be divisible by 4. That leaves me with a 2 and a 3. Now I multiply across and I get 2/33. That's method 1. Let's try it with variables. It's the same process. So in this case, the numerator is already one fraction, if you will. It's just a plus b over 1. That's my numerator. It's already good to go. This one, though, I do need to get a common denominator. So between a and b, my common denominator would just be ab, meaning this one got multiplied by b over b. This one got multiplied by a over a. So now I can rewrite that as b plus a all over ab. That numerator stays the same so far. Now that I've got one fraction on top, one fraction on bottom, I can do my rule, which means flip this guy and multiply it. So ab on top, b plus a on bottom. Again, I can look to cross cancel, and this is a nice one because a plus b and b plus a are the same thing, so those can cancel out, and my final answer is just ab over 1, which is just, oops, sorry, there it is, just ab. That's method 1. So method 1, again, you should have been able to remember that. That's kind of the original way they teach it. It's kind of what I call sort of the old school way. Method 2 in my mind is more of a shortcut. So the shortcut way, now I say shortcut, but it doesn't mean it's always shorter. Sometimes it ends up being about the same exact length as the other one. So it's not necessarily always shorter, and you'll see that as I go through these examples. The goal here is to look at both numerator and denominator and find an overall common denominator. I call that the OCD, overall common denominator. You're going to multiply everything, numerator, denominator, every single term. In this case, there's 4 terms. I'm going to multiply every single term by that OCD so that the fractions now all disappear that are within there. So watch what happens. I've got a 3, a 4, a 2, and an 8. So my OCD between 3, 4, 2, and 8 is 24. That's going to be the common denominator between all of those, right? So everything goes into 24. So I'm going to multiply every single term by 24. So what do I mean by that? I mean, I'm going to take this first 1/3 and multiply it by 24. Multiply this by 24. Now you're really multiplying all the numerators by 24. And they're going to cancel out with each of these denominators because it was an OCD. It was in common from all of them. So now what's 24 divided by 3? So that just gives me 8. 24 divided by 4 is 6. 24 divided by 2 is 12. and 24 divided by 8 is 3. And now I multiply those remaining numerators. So here I'm going to have 8 times 1 is 8, 6. On the bottom I'll have 12 times 1 is 12, and then 7 times 3, 6 minus 2, 12 plus 21. Notice I got the same answer as I got with method 1, but just a different way to do it. Okay? In this way, you won't have to reduce at the end because you should have, if you really did the overall common denominator and it was the least common denominator of all of those, then you should have been canceling earlier on. Let's try the same method now, but with variables. So again, what would be the overall common denominator? So remember the denominator here is actually 1, and my denominators here are A and B. So my OCD for this one is just AB, because that would be my common denominator here. So I'm going to literally, again, multiply every term by AB. Okay. Up here, when I multiply by AB, nothing happens. It just stays there on the top. So I have A plus B times AB. It's all here. This is all together because it's together in that one fraction. Times AB, the 1 in the denominator, excuse me, doesn't do anything. So that's my big numerator now. Down here, though, things do cancel. So the A will cancel with this. B times 1 is B. The B will cancel here. 1 times A is just A. And then I have these two that are going to cancel out. Hi. And I just get A, B. You're good. Just making a quick video. Okay, so again, you're going to get the same answer that you noticed for this one up here. A, B, same answer, but it's just a different way to go about getting it, right? Using that OCD to cancel stuff out instead of the others. So again, this is up to you how you want to try it. At the bottom, I'd like you to try both of these with both methods, and then pick the one that kind of resonates more with you. And the rest of the worksheet, I want you to stick with that method. I don't want you bouncing back and forth and trying to do one or trying to do two, because you're going to get them mixed up in your brain. So pick one that sticks with you and use that method, okay? I'll walk you through them again, and then you can kind of pick one, which one works for you, okay? So let's try this one. Method 1 says, take that numerator and find a common denominator just of the numerators. So between 4 and 6, common denominator would be 12. So this would become 3 12ths, 10, 13 12ths. Now that denominator stays the same. I flip it and multiply. And I can cross cancel here. Leaves me with 4. So what is that? 13 eighths. All right, that's method 1. Okay, common denominators, flip, and multiply. Method 2, look for the overall common denominator. So between 4, 6, and 3, my overall common denominator would be 12. So I'm going to just rewrite the problem here. Multiply each term by 12. Cancel. So that first one gives me a 3. Cancel, right? 3 times 1, 5 times 2 is 10. Cancel. 4 times 2 is 8. And I get 13 eighths. So if you're pretty quick with common denominators, looking and seeing that stuff cancel out right away, and getting rid of the complex fraction, that's method 2. If you really like the more step-by-step, methodical process, use method 1. All right, last example, let's go through it. Again, with variables, method 1, method 2. So method 1, I'm going to just look at my numerator. Common denominator between x plus 1 and x, you have to put both of them there. Okay? So that common denominator is x times x plus 1. So the first one, what's it missing is an x, so it would now have an x on top. The second one is missing x plus 1. So now when I add across, this is going to give me x plus 1. What's x plus x plus 1? Well, that's 2x plus 1. And then I still have this on the bottom. Let's do the denominator. Same idea. I'm going to have both x plus 2. The first one gets multiplied by x. The second one gets multiplied by x plus 2. So now I can distribute this one out. I'm going to need more space, I think, here. Distribute here. Okay, so I'm going to have here now 2x minus, when I distribute this, I get negative 2x. This is a negative 2 times 2 is negative 4. X plus 2 on the bottom. Now those two x's are going to disappear. So then I just have, for my denominator here, negative 4 over x plus 2. But now I got to do my fraction rule. Multiply by the reciprocal. What cancels out? The only thing that disappears are these x's, because x plus 2 and x plus 1 are different. It's got to be the whole thing to cancel out. And this negative 4 can't cancel with anything here since that's being added. So final answer, it looks like I would get 2x plus 1 times x plus 2 over negative 4 times x plus 1. That's why we call these complex fractions, right? All right. Is method 2 going to be any easier? Probably not. I'm just going to get some scratch paper so I can show you it because I don't have enough room. So let's do method 2. I'm going to rewrite the problem and do the same thing down here so that you can see it. So I've got 1 over x plus 1 plus 1 over x over 2 over x plus 2 minus 2 over x. Now remember, this is the OCD method, meaning I got to find the overall common denominator. Well, they definitely both have that x in common, but x plus 1 and x plus 2 are different, so I have to include both of them. Then I have to multiply each one by x plus 1, x plus 2, the whole thing. X plus 1, x plus 2, x plus 1, x plus 2, x plus 1, x plus 2. Now we get the fun part. This is the canceling part. So x plus 1s are gone. X is gone. X plus 2 gone, and x gone. So let's see what's left. Here I'm left with x plus 2 plus x plus 1 times x plus 2. Down here I'm left with x plus 1 plus, minus 2 x plus 1, x plus 2. Okay, so it still doesn't quite look like the top one, so we got to do a little bit more work. So we can do some distributing here. We could do another factoring method if we wanted to, but we'll go ahead and distribute it out. Okay, then you distribute the same idea is what would happen. What we could do is factor out. That's actually a little easier. On the top, notice that they both have an x plus 2 in common. So I can take out an x plus 2, and I'm left with x plus 1. And on the bottom, I can take out an x plus 1. If I take that out of both, I'm left with x minus 2 times x plus 2. Combine like terms up here. So now I've got x plus 2 times 2x plus 1. Down here I've got x plus 1. Distribute. Super close. Combine like terms. Final answer, x plus 2, 2x plus 1 over x plus 1, negative x minus 4. Is that the same thing we got? What did I do wrong? All right, I will figure it out and try again, because I just am supposed to have a negative 4 there. Minus 2x minus 4. Where's this x coming from? Oh, there it is. I lost my 2. I found my mistake. So there was a 2 here. So that should have been 2x minus 2 here. So those were gone, and then it was just a negative 4. And now we're good. Now it matches the other one. Okay, so again, even though I say shortcut, it wasn't necessarily shorter. On this one, it was pretty long, so it just kind of depends which one you like. Pick the method you like better. I'm a method 2 girl. I always do method 2, but you can definitely do method 1. Your final answer, no matter what, should be the same. Okay, so you're going to work through the rest of this worksheet and check your answers like always. Good luck.